Hello everyone and welcome back to another video. Today our topic is going to be the trigonometric ratios of right triangles. And this is a topic that you're going to see in Algebra 2 Trig, a course that you might take in high school, or even in pre-calculus. So let's get on with this video. First of all, we're going to look at what a right triangle consists of. So I'm going to draw a right triangle. Obviously, it has three legs. One of the legs is going to be the hypotenuse. So I'm going to label this leg, the longest one, as the hypotenuse. And then this you can name like A, B, C. And obviously, if you think back to the Pythagorean theorem, the formula for finding the hypotenuse is A squared plus B squared is equal to C squared. So that is the formula you're going to be seeing a lot, especially when it comes to solving with right triangles. Anyways, so as we labeled this side the hypotenuse, I'm going to write it again. This is the hypotenuse. Now, if we're looking at angle theta from this side, let's say this was our angle theta, then our side A would be our opposite side, because it is directly opposite to side theta. And this side would be our adjacent side, because it is directly adjacent to or next to our angle theta. And I'm going to erase this C, move this down a little bit. Okay, and then obviously this is our 90-degree right triangle. Okay, now that we have this settled, we're going to be looking at what you might have heard as being called SOHCAHTOA. Now, the S stands for sine, C for cosine, and T for tangent. And these are our opposite and hypotenuse, adjacent and hypotenuse, and opposite and adjacent. So we're going to look at how we can create an equation using these trigonometric functions. So I'm going to move this up a little bit. And let's get started with sine of theta. So sine of theta, if we look at our SOHCAHTOA, we have opposite and hypotenuse right here. So opposite and hypotenuse. And the way that this works is it's always going to be whatever your thing is, like O over H. So the first one is going to be divided by the second one. So it's going to be opposite over hypotenuse. And if you look at the triangle, it's going to be this side, so the opposite of angle theta down here, over the hypotenuse distance. All right. Next up, let's move to cosine. Cosine of theta. Looking at our SOHCAHTOA, we have adjacent and hypotenuse, so we're going to be dividing the hypotenuse from the adjacent. So adjacent divided by hypotenuse. Great. And now we're going to look at our tangent of theta. And going back to cosine, our cosine is going to be our adjacent to angle theta divided by our hypotenuse distance, just to clarify. And then our tangent of theta, looking back at our SOHCAHTOA, we have opposite and adjacent. Adjacent is opposite divided by adjacent, basically. So opposite over adjacent. And these are our three basic trig functions: sine, cosine, and tangent. Now, we also have three more. These are going to be the reciprocals. So I'm going to put a comma in between all of these. And then we're going to look at the reciprocals of sine, cosine, and tangent. So the reciprocal of sine is cosecant. The abbreviation is CSC, cosecant. You can see how it's spelled, cosecant. Cosecant of theta is going to be equal to, Now, if it's the reciprocal of sine, first we can write 1 over sine theta. Now, if it's the reciprocal, we're going to have to switch the numerator and the denominator. So hypotenuse and opposite are going to be switched. So it's equal to hypotenuse over opposite. Now, just like there is SOHCAHTOA, I haven't heard one for cosecant, secant, and cotangent. I don't think there is one, but one way to always remember it is just switch the numerator and denominator. So cosecant is going to be the hypotenuse over the opposite, so hypotenuse over the opposite of theta. Okay, moving on to secant. Secant, the abbreviation is going to be SEC, secant of theta, is equal to 1 over cosine theta. And if cosine is adjacent over hypotenuse, 1 over cosine is going to be hypotenuse over adjacent. All right, and to look at the triangle, hypotenuse, this one over adjacent of theta. Okay, and finally our tangent. Our reciprocal for tangent is going to be called cotangent. And we're first going to write it as 1 over tan theta. And if tangent is opposite over adjacent, 1 over tan is going to be adjacent over opposite. And that is it for the 3 or the 6 trigonometric functions that we're going to be looking at throughout, that you are going to be looking at throughout trigonometry, pre-calculus, anything that requires right triangles and trigonometric functions, basically. So now we can look at some examples regarding this first part that we looked at. So I'm going to draw a couple of triangles. First one, we're going to draw right here. So if this is our right triangle, okay, just pretend this is a 90-degree angle. And then remember that this is our hypotenuse. This is our if this is theta, this is our opposite side, and this is our adjacent side. So let's say we were given this triangle with all of the numbers in so far. So 3, 4, and 5. 3, 4, and 5. A 3, 4, 5 is a Pythagorean triple. You can also see this in renditions like 9, or like it can basically be any multiples of 3, 4, and 5. And if you can figure out that it's a 3, 4, 5, good for you, because then you can figure out the third side, or you can use it in trigonometric ratios. Anyways, so let's see what this problem wants us to solve. In this problem, I'm going to be asking you to find the 6 trigonometric functions, ratios of the angle theta in this triangle. So we're going to start off with our sine theta, cosine theta, and tangent theta. Feel free to pause the video right now if you know how to solve this problem. I'm just setting up how I would solve it. Cosecant theta, secant theta, and cotangent theta. Okay, great. So we have our problem set up. So remember that sine is opposite over hypotenuse. For beginners, if you want to write your ratio first, you can go ahead and do that. And then we're going to find our opposite to theta, which is 4, and our hypotenuse is going to be 5. So we will have 4 over 5. It's as simple as that. Box your answer just to be safe. Oops. And then cosine is going to be, if we look back up, we see that our cosine is adjacent over hypotenuse. And I'll write out SOHCAHTOA here. Adjacent over hypotenuse. We look at our triangle. Our adjacent is 3 and our hypotenuse is 5. So we're going to fill this out. 3 over 5. Pretty simple. Our tangent is going to be our adjacent, or sorry, our opposite over our adjacent, so 4 over 3. Sorry about that. Okay, so tangent is O over A, 4 over 3. And then our cosecant, remember, it's 1 over sine. So we're going to flip around our numerator and denominator so that we get 5 over 4. Secant is 1 over cosine. We get 5 over 3. And then cotangent is 1 over tangent. And these all have theta. And this is equal to 3 over 4. All right, so we have learned how to solve for all of the 6 trigonometric functions and ratios. Okay, so I will do another example problem, and I'll start off by drawing a right triangle, and then we will solve the problem from there. So this is our right triangle. So the problem says that the tangent of theta of this right triangle is equal to 12 over 5. And then we want to find the other 5 trigonometric ratios. So if tangent is 12 over 5, we know that tangent is equal to opposite over adjacent. So this is our opposite side. And if our opposite is 12, so our opposite is 12, we're going to mark this side as being 12. And then if our adjacent is going to be 5, like down here, our adjacent is going to be corresponding to this side length. So now we know the 2 side lengths. All we have to do is find the length of the hypotenuse, which is super easy if we solve for with using the Pythagorean theorem. So we're going to be doing 12 squared plus 5 squared is equal to, and we'll call the hypotenuse c squared just for the purpose of this example. So this is going to be c for now. And if you solve this, you're going to get that c squared is equal to 169, which means that c is equal to 13. And 12, 5, and 13, they are also another Pythagorean triple. So it's super helpful to memorize the Pythagorean triples because you're going to be seeing them pretty often. And it's a super duper easy way to get an answer instantly when you're thinking of right triangles. Anyways, so we are given now that the hypotenuse is 13. So we have all the 3 values of the legs of the triangle. So now we can solve for the other 5 trig ratios. So I'm going to set this up again with our sine theta, cosine theta, and we already know our tangent, but I will still write it out here in case. And then comma, our cosecant theta, secant theta, and cotangent theta. So now we can solve for our sine. Remember our SOHCAHTOA. So sine is opposite over hypotenuse. So opposite over hypotenuse. 12 over 13 is our sine. Cosine is going to be our adjacent over hypotenuse. So this one over this one. 5 over 13. Pretty straightforward so far. Tangent, we already have, it's going to be 12 over 5. And then cosecant, secant, and cotangent are just going to be the reciprocals of sine, cosine, and tangent, respectively. So this one is going to be 13 over 12. This one is going to be 13 over 5. And this one is going to be 5 over 12. But you can still solve for cosecant, secant, and cotangent by their values. So then cosecant would be hypotenuse over opposite, secant would be hypotenuse over adjacent, and then cotangent would be adjacent over opposite. If you want to look at the triangle and solve for it, if you don't want to do reciprocal values for each pair. All right, so that sums it up for today's lesson. We briefly went over what the trigonometric ratios are of triangles, and then we went more into depth when it came to SOHCAHTOA, and we did 2 examples today. Hopefully this helped you learn a little bit more about SOHCAHTOA and how you can utilize it when it comes to trigonometric functions and ratios. But other than that, if you have any questions, feel free to email us at exceledlearning@gmail.com, or you can drop your question in the comments. Please forward this video to anyone who you think it might benefit, especially high schoolers in this time during the COVID-19 pandemic, or people who are taking trig in school. Either way, be sure to subscribe to us on YouTube, follow us on Instagram at exceledlearning, and we'll be happy to hear from you anytime soon. Bye!